No, yeah, I got well, I have my old student version, which is a Bundy, and then I have my professional one is a Cannonball, and it's an alto as well. Would like to get the tenor sax version of that one, but it's a little on the expensive side.
That's why I went with the cheap Amazon version.
Yeah, both me and my son end up playing, so but yeah, it's really nice. How long have you been playing?
Since I was in 5th grade, but I never really did much outside of school, I guess, with it. So
No, okay. Yeah, same thing here, 6th grade, and been playing for quite a while. Although I don't think the last time I picked it up was probably maybe about ago. So it's been a while for me.
I understand.
I got distracted by playing with robots.
It's a good distraction. It's a really good distraction.
Well, welcome everybody. I think we'll get started. You can unmute yourself anytime in this meeting. So if I just turn off your dog, don't take any offense. You can turn your dog right back on. Dogs are welcome here, especially this time of day. So it looks like we're full enough to begin today's meeting. I want to thank you all for coming today. I know you're from all kinds of time zones and you were absolutely zoomed out with where you've been in the last year. And I appreciate having your attention today and a little bit on Wednesday and Friday, and hope to make it an event totally for you. And I hope that you get out of this what you need. And I encourage you to, just unmute your microphone and keep us moving in the direction that you need us to go, or if you have questions to get answered, whatever. This is the Cyberbot Distance Learning Workshop, and there are no prerequisites for this. This is our 4th or 5th series of these since distance learning began, and we were not able to go travel to different locations to train teachers. So we've actually trained over 500 this way since last March. And it's worked out pretty well. Today we're working with the Cyberbot. This is my favorite robot. It's actually our most popular robot at Parallax, and it came out about 2 years ago. It's got all kinds of uses, as you're going to see, and it's a combination of electronics, Python scripting, problem solving, reading to use this robot. So it's a fun challenge, and there's a whole bunch to learn. And it's one of these things where your students will likely fail until they win, which might be the first time for them, depending on their age. But the wins are big, and it's like a puzzle in a way. So anyway, my name is Ken Gracie. I'm from Parallax, and I'm the CEO of the company. Don't be impressed. I have my hands in everything. What do I do? So I have my preliminary CTE credential in the state of California, which has lagged lately because I've been too busy working. But in the classroom, I have about 7 years of work in high school level and middle school. Loved it very much, but I had to get back to my job. And I like working with CNC equipment, playing clarinet to distract me from robots and outdoor activities. And I am joined by Josh Coryell. Josh, who are you?
So I'm Josh Coryell. I am with cyber.org. I'm a curriculum development specialist here, and I mainly focus on just mathematics stuff. That's what my background is, but more recently, more programming projects, and like, for example, with the bots and any STEM-based curricula here at cyber.org that we've been working with. But as that says, and as the picture shows, I do play saxophone, or I have for a while, and then I'm also an avid taco eater. I love that description.
You didn't know I was going to put your picture here and do
No,
this.
I didn't realize that. I happen to be wearing the same shirt at this moment in time as well.
Well, you keep it simple. One blue t-shirt, all activities. Okay. So as you figured out, the project working on the Cyberbot is actually a joint effort of Parallax and cyber.org. And briefly about Parallax, we're located in Rockland, California. We've been in business since the late 80s and very big in education since about 1997. And we have a staff of 20. So we're an American manufacturer of robots, microcontrollers, and educational curriculum. And Josh, do you want to introduce Cyber?
Yeah, so at cyber.org, we create cybersecurity related curricula, and we go out and we, except for the last year, I guess, we'll go on site and we'll train teachers in that curricula, and we also have curriculum surrounding the Cyberbot as well. So we go out and we do professional development with that.
And I'll be connecting all of you to the cyber.org free resources. Probably many of you have not heard of them, but they have a lot of Microbit material that we can use in our classes. So here's the agenda. You have to squint to see this, but just very, very briefly, this is a hands-on class, and we're going to be doing as much building and programming together as we can. And so I'll try to minimize the talking. And in keeping with that, today, Monday, our goal is to get the Microbit connected to our computers and go to the Python editor, and then we're going to add a module, a code module to it, and we're going to center 2 servos. And I'm focusing on the big gotchas that you experience in class here, because the tutorials are very easy to follow, productive. There are probably 300 pages of them now, and I'll get you the links to those as we start to use them. But the areas we'll really focus on here are the things you need to know as a teacher so you can succeed. On Wednesday, we'll start writing some scripts for driving around so we can make the robot go, and I'll show you all the different ways to make it work. And then we'll build our first circuit, which will be a whisker circuit, and then I'll send you with some homework. There'll be a little bit of homework each night, like an hour. So it's pretty easy. We're keeping this light duty. And then on Friday, we'll move into some of the more advanced circuits, and I'll task you with building one of those by on your own. And then we'll talk about some different little pieces around the Cyberbot. How to use it in class, what are the educator resources available, and what are we seeing done? What are we seeing done by other educators? And you're all welcome to jump in and share what you're doing. So some of the goals I have for you are to enjoy, participate, have a good hands-on experience, see what's available, learn about electronics, how to build a circuit from schematic if you haven't before. And if you have, great, then maybe Python is new for you. And just to give you the confidence that you need. I often work with a lot of educators. I answer the educator hotline at Parallax. And I know it can be terrifying to go in front of a class and not have the answers. And so I try to focus on, how you can learn and teach your students to learn, to find the answers, and that it's totally okay not to know them. All this is brand new. Okay. The Microbit 2.0 just came out. I haven't even coded with it yet. And the robots just keep evolving. So you can never be totally current on this. Yeah. So we'll build the robot, we'll program it, and answer your questions along the way. And this is a little bit about you. So I asked some questions when you signed up for the class. You have a whole variety of experience with all kinds of physical computing and languages, as you can see here. Many of you have 3D printers, laser cutters in your class, and you're using all kinds of operating systems, mostly Windows actually, fair number of Chromebooks and some Macs, most of your high school teachers, and then of course, you're always very appreciative, and thank you for coming today. So you live all over the place, not surprising. And there are even a few of you, I believe, from Canada who snuck in, and we shipped you some robots, and one from Sweden who's staying up very late today. And maybe there are some of you who didn't even get robots because we shipped them. We had about 20 that shipped to your schools when you specified a home shipping address. So our sales staff made a little bit of a mistake, but we tried to fix all those. So some of you might wind up with 2 robots. And if you don't send it back, I won't tell our sales staff, and that'll just give you a head start for your class because you always need more robots. So yeah, and feel free to use the chat like you're already doing. And if you don't have the robot and you need to relive all this experience, we're recording this to YouTube. I will send out the links, and you can redo everything, within 3 hours of the day we're done. Okay, because it takes a little bit of time for Zoom to do its job and then for me to get them up to YouTube. Yeah, so the recording is very helpful, like Cesar just said, and that's why we make them available. So interactivity, your questions, comments, criticism. I obviously love hearing myself talk, but this is about you. So, you know, for us to be successful, for Parallax and Cyber.org, you need to be successful. And that means that you need to get everything out of this that you envision. So feel free to be more than a robot at our roundtable here and ask human questions. A little more about Parallax, just skip through this really quick. That's our office in Rockland. And I mentioned we're an American manufacturer and we've sold over 1 million robots through the years. And for all of you who are holding on to the discontinued Lego EV3, we welcome you to the world of Parallax and we'll help you get going. We also make our own chips for commercial products. Okay, so on Friday, here's something to look forward to. We're going to have an award ceremony and there will be wonderful gifts given out. We will have line follower kits, ultrasonic sensors with servos. We will have remote controls. We will have, I don't even know what we're going to give away, but I know we're going to give away some cool stuff. And there are 3 categories you can keep in mind for this week. And hopefully you'll have a submittal for one of them. Category 1, where you see my cat Fluffy. This would be your funniest animal or coworker. Try to include a robot in the picture. And although this is the Cyberbot and we're programming in Python, sorry, no more Python snakes. Those awards have been given out. So any other animal, nothing against Pythons. It's just that ran the course really quickly last year. So category 1, again, will be the funniest animal or coworker. Category 2 will be the biggest winner. That's where you combine circuits and you write your own scripts and you do something impressive and you show that to us. Category 3 is the biggest fail. We'll definitely have some of those. Fail often and proudly. Some examples. Here's one. This was a fail. And so obviously I'll be asking you to collect videos and pictures or a little narrative, and I will give you instructions on how to submit this. But what could be wrong here aside from the video not working? Like you see right now. Anyway, since the video is not running, what is wrong here is that the microbit, here we go. So this particular teacher just couldn't figure out what was wrong. And we had many pictures and efforts to help, but it turned out that the microbit was upside down on the Cyberbot board.
Oh, you can see, yeah.
Yeah, you see that? So
Yeah.
she proudly submitted, failed hard, and won a line follower kit, and is probably with us today getting more training, is one of my winners.
Cool. I think we should have a most pugs competition.
Oh yeah, well you'd win that one. So I want to see
I
that.
think so, yeah.
Your pug riding on a robot.
When you have 3, it's a grumble.
I bet. And then here was a cool one where, let's see, I think infrared was combined with whiskers and a little bit of an advanced script. So sometimes infrared can't see the object, but whiskers will detect it. So you'll learn a little bit about sensing this week. No single sensor solves everything. Okay, so there was already a question for links. First off, I'll give you a link to what we're using today. And it is getting posted right now. Boom, this is our Google presentation. So I'll send it out again tonight. And you can follow along or get ahead this way. So there's a lot of resources we're going to use. These are on page 17. You can just copy paste them into whatever you do to keep track of things, or just come back to the presentation. So there's so many, I'm not even going to read them all right now, because we're just going to head straight towards hooking up the microbit as quickly as possible. Everybody good with that? Any questions so far? Okay, nobody's scared? Good. All right. Python plus robots. That's
I have
what
a
we're
question.
doing. Yeah.
I'm sorry. I apologize.
Catherine.
I did not get a chance to put my microbit all together because I couldn't find, and that's my error. I couldn't find the actual guide for instructions. So am I far behind today?
You are right where we need you.
Okay, great.
Yeah. Yep. So all we need today is the microbit, and then I will show you how to center servos, and a few of you will follow along and do it. So yeah, you're okay if you've not done anything. Updating the firmware would have been a good step, but I find it's not really necessary. So we're going to be combining Python with robots and circuit building, and those three pieces are a lot. So something will always not work until you make it work. What's so great about this? Students like this. Okay, so the only class I remember in high school was the one where I was using my hands and my brain, and everything else, like me talking to you, I think I remembered 5% of it. So I want to also get you towards actually working with the robot. So we're using the microbit. I'm just curious, how many of you already have prior experience with this? Maybe you could just leave a comment, or yeah, raise your hand or whatever. Yeah, okay, good. Mostly like block programming. Okay, good. It's great if you have any experience with it. It's good to see some familiar faces as I scroll through, like I see Carl too. Okay, so we're using the microbit. What's really neat is the version 2.0 just came out. I think that's what you have in your robots too. And you would be among the very few educators in the US right now who have the version 2. And if you're new to Python, you know, it seems to be the latest language that's gaining huge popularity. It's the fastest growing language at the moment. And I like it because it looks like BASIC to me. And I've had a lot of trouble learning C through the years. And I've just found that Python, although I don't use a whole lot of it, it's a lot easier to learn, and I can find the resources I need and make it do what I want. So it's very popular. It reads like English, it's extensible, it's object oriented. And what's cool is it runs on the microbit. So it runs on this too, on our little controller that you have. And all the tools for it are totally open. So you can program in a browser, and it forces good practices. So you'll see we'll all get some errors when we first write some code, and then we'll have to find and fix those errors. So a little bit about putting it into the microbit. The microbit came out before this Python language came out. And like many hackers do, they find other purposes to use their hardware. And one of them, this guy in Australia named Damien George, put out a Kickstarter to create a Python interpreter for the microbit. And he got funded, and now his Python interpreter is widely used. And it basically extended the microbit from elementary school all the way through university because of Python. Because you take this language, the ease of programming, and you have hardware that you have enough sensors on, and you have a built-in radio. It's like, hey, there's a lot there to work with. So the new Microbit 2.0, which you have, has far more memory for this Python language. So it used to be a year ago, before we could talk about the Microbit 2.0, we'd have teachers that would run into memory limitations by writing a page and a half of code or so. And then they had to stop, and we had to really work together to figure out how to save memory. But now the 2.0 has between 3 and 5 times as much memory on the Microbit for Python. So those issues are gone. You can write big complex programs integrating several sensors and the radios and do a lot of stuff. I'll just point out there's a lot of hardware on the microbit. There's a radio, there's accelerometer, and by radio, I mean RF device, wireless communication. There's buttons, there's a display, there's a speaker, there's a microphone, I think. Yeah. Okay, if you have any of these computers, you're good to go. So that pretty much covers every computer. All right, it runs on everything. Educational resources, we're going to fly through this really quick. So we'll come back to this on Wednesday and Friday, but there are many resources available for the Cyberbot from cyber.org and from Microbit Educational Foundation. They're all very good. And there's a lot on Hackster that I liked for teachers. And then there's the Parallax material too. So I'm just going to copy in a link right now for the Cyberbot into the chat. How about if I just show you how to get here? I think that might be easier. So you just type in learn.parallax.com on your browser, and you don't have to do this yet. Just follow me for a moment, and then scroll down, until you find, you could search by language or by grade or whatever, but we'll just go down to Python. And if you click on there, you'll see 2 series, the Cyberbot and then What's a Microcontroller. And we'll talk about the What's a Microcontroller on Friday, but if you click on Cyberbot, then you come into all of the tutorials, okay? So as an instructor, you have your students follow these just in sequence, and sometimes there are prerequisites and we take you back to other sections of the tutorials, but you're looking at 300 pages here. All right, it's the most well-documented robot we have, I think, next to the original Bobot. Any questions on this so far? Thanks, Josh, for dropping that in there. So a ton of material, and you'll notice here towards the second half, there's a lot on cybersecurity. All right, that's for Friday. That's because our sponsor of this, cyber.org, has a mission to create more cybersecurity ready students in our country. And there are also some projects at the bottom. So software, okay, we're doing okay. It's 2:22. We just want to get our Microbit hooked up to our computers together and see that we could download some code to it. And then we're going to add a code module to it and center our servos. So what you could do is grab your Microbit and then your USB cable. Get those things handy. And then I'm going to take you to the Python editor. Also just going to take a minute and rearrange my screen sharing so that you could also see my Microbit while we do whatever we're going to do with coding, along with a Python editor. So just bear with me a moment. Got this really cool document camera. Microbit. So what I'm going to do is just plug in the cable first to the Microbit. And just set it here. Now, first things first, what's really great about what I've just done is the Microbit actually comes up on your computer as a hard drive, which is wonderful because there is no software driver installation required to get to this stage. So next thing I'm going to do is take you to the Python editor, and I'll paste a link in there unless Josh gets there before me. Okay, so I pasted a link in the chat. If you go ahead and click on that link and open up the editor. And if you can't find the cable, okay, like in Veronica's case, you're far out of our country, so I can't easily get you one. It is just a standard USB micro cable. Okay, so there's nothing very special about it. Hopefully you have one, say from like, could be a phone or maybe a digital camera, something like this. All right, y'all with me so far? Maybe a shout out would be good.
We're good. I'm good.
Okay. Okay, good.
A little behind, but I'm getting there.
No worries. And by the way, I have 2 people here from cyber.org who can help us. If anyone falls behind, I have Matt Kinman too, and we could always start up a breakout room and drop you in there.
Okay, I remember this part from last year.
Yeah, you have to redo these things to really get it into the head. So we're all connected. The next step here is I want to show you how to connect the Microbit to the programming tool and then flash some code in it. Okay, so you've connected it with a cable. The Microbit's getting power from the cable from your USB port. So you can download this way and you can run programs on it. So the first thing I'm going to do is go up to this connect button in the editor. and it's the one that has this kind of, I don't know, broken link in it. And I'm going to click connect, and I see a message, and it says Python editor 212 microbit.org wants to connect, and there's a device there listed. So if you had 3 or 4 microbits here, they would all be listed. So you'll see one. Okay, so you just click on that and then click on connect.
Oh, I see.
All right. And after, oh, okay. So on mine,
Watch.
let's see here.
Hello world. Watch this. Here it comes.
Unable to claim interface, new error I have seen. Just let me see what's going on here. That might be a situation where my microbit is an older firmware. So I'm just going to try a different one. Pause with me for a moment. Okay, so I successfully connected. So once you've connected, by pressing that second button on the top, it will say disconnect. So if you clicked on it again, then it says connect. So if you click connect, you'll remember what was connected, and then it will enable the button on the far left, and it will go from download to flash. Okay, so this is a big step, because once it says flash, you can put this script, and when I say script, I'm talking about code. Okay, you can download this code directly to the microbit when this button says flash. So I'm going to go ahead and do it, and I'll bring my microbit back so you could see it. So I press flash, and it gave me a message flashing code, and it says hello world. So I could change this, and you can do it too. So I'm just going to change it to Josh plays saxophone, and then I'm going to reload it, and you'll see the message has now changed to that. But you have to be laying on your side to read it. Okay, that's a little bit better. Yeah, and apologize for the lighting not being perfect in here. And then there's a heart at the end. Okay, so let's do a quick check and see where there's trouble. Who's having trouble getting the connect and flash to work? And we can go over it again. Don't be afraid now. Everyone's got it? I see some thumbs up.
I have, I was able to get it connected, but I'm gonna have to log in with my other computer to see what you're doing, because I'm getting
Okay.
lost.
Yeah, it's a tricky thing where this is like absolutely pushing Zoom and people to limit, because you are watching a presentation, then also I'm asking you to do certain things in code and connect, and so it's challenging, but that's why we got the video, so don't worry. And for Wednesday, set up another display and run Zoom on it, and then have one for your editor. Okay.
Mine is still flashing.
Okay.
Well, does it take a while?
No, it should be the first time you connect and you flash, it might take like 30 seconds. And then a number of settings are saved, and then it will be quicker for all the changes you make. So when you did that, John, did you have the flash button? I just want to make sure you've actually downloaded your code. Is your flash button showing up as flash, or does it say download?
No, it says flash.
Okay.
And it's there's the message in the middle of the screen saying flashing, MicroPython, and it's about 50% done right now. That's why I was asking.
Okay, it's just taken a long time. Yeah. So what you'll notice is I'm glad you brought that up. So first time it does take up to like a minute, as I recall, until your microbit knows who it is and where it's living. And then the second time and third ongoing, it'll be really quick. So let's make sure yours gets done, because there are probably other people in the same situations. And for Veronica, Josh or Matt, maybe you can help Veronica. I think she has a pop-up window, but nothing happening. So maybe you could direct message to her.
I know he's.
And okay, John, you're still downloading? Oh, it succeeded?
No, it's still downloading. I'm about 75% done now.
Okay.
My download out too, but now it's okay.
All right. So for those of you who have downloaded, change the display text that you're scrolling to something else and flash it again and just make some changes like that. Maybe put another line, copy and paste that display.scroll, put a second line under it, like I have just done, an experiment. So just get yourself comfortable typing in the editor for a moment. And in a moment here, we're going to move on to obtaining the Cyberbot code module and putting it on the Microbit. So for those of you that are already up to speed, just pause for a few minutes and we'll do another check in a minute. Yeah, so just reading the comments, what a great teaching tool. Yeah, there, I have to admit, for $18.95, there's a lot packed into this module. With all the sensors, and we haven't even explored the sensors, but a lot of them are very good for robotics, like the radio and the accelerometer. So if you're way behind, that's okay. I just got a message and I'll ask Matt Kinman if you could, or Josh, see if you could reach out and give Veronica some help. Okay.
I believe Matt is.
Oh, Matt is. Okay, cool.
Yep.
All right, so we'll move on. Next thing here. Let's reshare the presentation again. Okay, so you can go to Google and then search for BBC Microbit Python documentation. Maybe Josh can grab a link to that and drop it in chat, and it will show you all the possibilities. So just like our engineers at Parallax do, if we're designing a product and we're using a new processor, we got to find the documentation for it. So Matt or Josh will paste a link and there it is. So it's readthedocs.io and it's available in many languages. And you could run tons of sample programs out of that. So couple things here before we actually add the Cyberbot module. In the slideshow I'm showing, which I'm going to paste again into the chat, I have written for you a number of short programs that you can copy and paste and run on your own. So just looking through them, yeah, I'm glad you guys like the docs. Andy and I put a fair amount of time in them with Cyber just to try to get this presentation right. And the docs you're looking at are fantastic, by the way. So go ahead and you can go through some of these. You'll see that the Microbit module has a whole bunch of pre-made images. There's, various emojis, hearts, small hearts, check signs, and you can make your own, and you can light up, individual pixels like you're seeing here. And just change these up to do all kinds of stuff. There's random, there are commands for delays, there are commands for math. So this LED display provides really good feedback, especially for robots. You can use it to show which sensors have been activated. Here you're seeing an animated GIF where we're using a repeat loop or a for next loop that counts from 0 to 5 in steps of 1. But it's actually 0 to 4 because in Python, that second value you see is -1 or considered exclusive. So this is just a LED illuminator for column 0, which steps through each LED. So that's a fun one. And you can solve math, of course, make decisions. And if you're totally new to this, you'll see this is a pretty basic looking language. And if we have Python experts who already teach Python, I encourage you just to jump in and identify other ways to do things and whatever you want to point out. So a couple buttons on the microbit you can use as well. And we're also going to turn it over in a little bit and look at a button that's on the back, which is called the reset button. It's that little black button. So we will sometimes say, press the button. We'll try to differentiate between the reset button and the buttons on top. So that reset button resets the module and starts your program over. And these buttons on top, which are called button A and B, are just for human interface for whatever you might want to do. And here's an example of pressing the buttons and then showing either a check or an X. There's a temperature sensor, times 9 divided by 5 plus 32. Light level sensor. Okay, so there's a lot here. Didn't even talk about the radios yet. There's a terminal, and terminal will be new for us. We will learn about it by using it. Comments, briefly, you can do block comments with groups of 3 quotes, and you can put them before the block you'd like to comment and then out, and then a hashtag, or as many of us know it, a pound symbol, can comment out a line of code. So nomenclature, we're going to come back to this because right now we are going to add a module to our microbit, and it's called the Cyberbot Module. Briefly, just going to switch over to my camera and we'll discuss how this interacts with the microbit. Okay, so this is a Cyberbot board with the microbit plugged in. I think you're seeing it, are you? Someone give me a shout out.
We see your PowerPoint right now.
Oh, okay, sorry. Okay, how's that?
Yep, we can see it.
Okay, so this is one step ahead of where we are at the moment, but basically it's a Cyberbot board and there is a microbit attached to it, which you'll do after class today, or maybe some of you already done it. To do the robot functions, there is a module, code module, that will live inside the microbit, and we will talk to it, and it will enable us to do things like control servos, ultrasonic sensors, and basically do things that the microbit cannot do on its own. So I'm going to show you right now how to add that to your microbit. And this is one of the trickiest parts of the entire process of using the Cyberbot. But once you've got this, you're really good to go, because a lot of times students will bring you the robot and say, I have a syntax error and I don't know what's wrong. And your first response can be, is the Cyberbot module on the microbit? Okay. So how do we do it? All right, I'll give you a link in the chat. And what I suggest is I actually go through it first and you watch me, and then you can do it.
The link's already in the chat, Ken.
Awesome. Okay, so I'll share my whole screen again, and you guys can follow me as I do this. Okay, so the link is in the chat. I'm going to click on it. And I come up with this. Okay, this is funny because we've built a new website. And so that's now the old link, and I'll need to update that. So I'm going to take you to the correct one. Bear with me for a moment. And it is in the tutorials as well, linked directly. However, I'm just taking us there through a product page. Okay. All right, that's interesting. Okay, so I'm going to paste this in. But before you follow me, let me just make sure everything here is working smoothly. And so it's a process of downloading and then unzipping and then adding something. And I think this is the right file. I'm just going to make sure. And this will vary a little bit by Chromebooks. I always get the call from Chromebook users. And I don't quite know what it looks like on a Chromebook, but okay, and where did it put it? Oh, and there's actually a zip and a zip this time, so we're gonna have a good time. It's like the Russian babushka dolls at Christmas time. Okay. There we are. So, all right, we'll go through that again. So here's the link, and just go ahead and click on it. And I will do the same again. So when I go there, I get this page. Oh, looks like I didn't actually put the right link in there. It's right here. Well, actually I did. Okay. Yeah. So you'll go to the product page and then go to downloads. And then the third one you'll see is called the Cyberbot Robot Kit with Microbit downloads. And if you click on that, it takes you straight to a zip, which you'll download. And put it somewhere where you can unzip it and find the contents. Okay. I have used my desktop, and my desktop is a mess, but for you, use your download folder or wherever you can put this file and find it. So I'll save it to my desktop. And Josh, if you could take a minute, go to the tutorials and find the tutorial page that has that link too. That would be helpful for them so they know there's an easier way than the way I'm getting us there. So once you've got that zip package downloaded, you can open it up and then extract it. And inside the Cyberbot MicroPython folder, you will see the following that I'm looking at. Okay, so Dalfra, that link takes you to a page that has the zip on it. So, and Josh also posted okay, yeah, now we're getting a couple ways to get there. Matt just put in the very direct link. So if you're having trouble finding the link, you could just use the one that Matt has posted, and that'll open up a zip for you right away. So go ahead, download that zip, and then unzip it. And then you'll probably need to unzip the folder that's inside of it. And you're looking for cyberbot.py. Okay, so once you've found that file, you'll know that you're in the right place. Maybe some thumbs up or thumbs down would be good, just to let me know who's making their way there. Okay, all right. See one thumb up, two. I don't see any thumbs down, so well, it looks like you guys are all getting it. Okay. All right. All good. And I just want to pause. I know this is a big step, and students will have trouble with this, especially as we raise them on Chromebooks. They don't have a lot of experience with file management as much, and using Google, everything lives somewhere in the cloud, but here we're dealing with source code files that you download, you unzip, and you have to have a management system to track them. Okay, so now I'll show you how to add it to the Cyberbot. And before I do that, I'd just like you to know that there is a video for it as well. And I will put that video and the page into the link. So later today, you can go there and do this on your own if you're having trouble. So it's on here it is. there's a little animated GIF that will take you through what I just showed you. So you're looking at it on my screen now, so don't worry if you're having trouble. Okay, so back into the Python editor. What we want to do now is add the Cyberbot module to the Microbit, and then we're going to use it to center the servos. And after that, you're going to be able to build your robot. Okay, so here's the process for doing so. Just verifying that my Python editor is being shared, Josh.
Yep.
Okay, cool. All right, so go to load save. It's the third button from the top. And you'll see this window. It says load, save, project files. You're looking for or browse for a file. It's in the first box. So if you click on that, it'll open up a view here to your files. And you want to go to where you unzipped the cyberbot.py file. And so on mine, it was on my desktop. And then when you get there, select cyberbot.py, then click open. And you'll see a message. The Cyberbot module has been added to the file system. Okay, so let's check and see that it's really there. And the way you check is you click on load save again. And as you go down to show files, now you'll see two things. You'll see the Microbit program and cyberbot.py. And how did I get there? I'll do that again. So this is how you verify. Click on load save. And then go down to show files, and it should say two. And this is often a problem where the Cyberbot module can disappear from the Microbit. I think it has to do with having multiple tabs open for the editor, and the tab wants to, the editor that you're using doesn't like it when you change, like when you have multiple tabs open, and just got to keep your interface simple here. So hopefully y'all see that now. Okay, so at this point, you would change this from Microbit import star to from Cyberbot import star. So you can go ahead and do that. And while I'm here, I'm going to save my program. So on the upper right-hand side, I'm going to change the script name, and I'm just going to call it center_servos. And then I'm going to click on save. Okay. And I am going to click on download project hex, and this will save it to your computer, wherever you want. And like I normally do, I'm just going to put it on my desktop and make a big mess. Okay. So
Are these directions, I'm sorry, I apologize. Are the directions on within a particular file? I'm just having a difficult time following along with doing.
Where we are right now is in the add modules to your Microbit on this page.
And I can find that from the presentation?
Yeah, so it's in the presentation, and
Okay.
it's also in the chat. So we're in this section, add modules to your Microbit. And the reason we jumped here instead of writing a lot of programs is because this is the trickiest part of everything. So you can go through this afterwards too, and just follow this page and you will succeed. And there are a couple ways to do this, by the way.
Ken, can you show one more time after you changed the name? What did you do?
Yeah, I did save. So I wanted to save my program. So I changed the script name in the upper right-hand side,
Right.
and I'm going to call it something other than whatever it was. And I just decided to use center servos. And then to save it. So right now we're in this browser and nothing is saved on your hard drive. And I'd like to download it to my hard drive so I could save the code locally. And by the way, once we flash it on the microbit, it is also saved there, but I like to keep a copy on my computer. So I click on load save, the third button, and you'll see in the middle, 2 different buttons you can choose from for save. One is download Python script and one is download Python project hex. I'll tell you the difference between the two since I didn't already. Python script is just a notepad text file of your Python code. Okay, but it does not include the module, the Cyberbot module that we just added to the microbit. So when you download project hex, that takes the whole project, not just the Python script that we're looking at, but it takes whatever modules you added. So if you click on download project hex, then you will get a window open up and you can save your code somewhere. Does that answer? Yeah, and you can experiment too. You can just download the Python script, but all you'll have is a text file that has these 2 lines of code on it. Okay, and so by the way, the from Cyberbot import star, that's a code module that includes from Microbit import star. So everything the Microbit can do, plus everything we need it to do for the robot is in from Cyberbot import star. All right, servo centering. So before you build the robot, and those instructions are right here on build your Cyberbot, you need to center the servos. Okay, and the reason we're doing it now is because there are 2 ways to assemble your robot, and one way you can adjust them later, but your robot performance is not as good. And the way I like to build them, and I'll show you the difference, I like to center the servos first before assembling the robot. And so this would be the second sticking point for your students when they do not center the servos and they build the robot. And this is also clarified in the tutorials quite clearly, but I'm going to just show you how to do it here. So I'm going to type in some code in the editor. Bot 18. Oh, actually, before I do that, we got to do a little bit of assembly. So let's switch off to the document camera. And we need to do just a small amount of assembly first. So what you probably have at this point, is the document camera showing okay, Josh?
Sure is.
Okay, good. All right, so I'm just going to back up a step here. And we'll go to the stage you're at, and then we're going to pull some parts out of the box. Okay, so here's what you need. I'm just taking mine all the way down. Okay, so you have a microbit. Like so. This is the version 2.0. And the parts you're going to need are these little pieces, and they're in a little bag. And you may have already found them if you received my email, but they're basically 2 flathead screws, 2 black acorn nuts, and then 2 nylon hex screws. Let's just get a really good look at them because there are a lot of parts in your kit. Okay, so we'll move them around just to make sure you've already got them. So these are cap nuts or acorn nuts, the black pieces. And these are nylon nuts, and these are 440 by 3/8 flathead screws. Okay, there are other types of screws in your kit, but these are flat on top, as you can see. Flat head. Flat head. Okay, so they come in a bag, a little bag, usually together, kitted up together. So what we want to do is we want to attach the Microbit to the Cyberbot board. And the process goes like this. So I'll take my Cyberbot board. Actually, I'm going to start with the Microbit. So I will take the flathead screw and I'm going to put it through the bottom, and the bottom is the side with all the components on it. Okay, and I'm using the outer two locations. So I put that screw through, and then I'm going to put the nylon nut over the top of it, and I'm going to tighten it down. So you have to be a little bit dexterous. Is that a word? With your hands to do this. And what I like to do is just hold that nylon nut and then take the screwdriver and tighten it, and you should have a parallax screwdriver. So that would be a finished and assembled side one. Okay, but there is another side, so we'll do that one now too. Then we're just going to attach it. Doing the same thing. Just going to hold that little nylon nut with my finger and then tighten it with the screwdriver. Okay, so you look at the bottom of the Cyberbot board, you'll see it has these little spring terminal connections on it. And these will line up with the Microbit metal pads when you attach it. So I'm going to go ahead now and attach it, and everything here is upside down. So I just put the Microbit board onto the bottom of the Cyberbot board, and it's got those screws have to come all the way through. Okay, so here we are, and the screws will line up the pads of the Microbit so they connect with those little springy terminals I showed you. Okay, so at this point, the Microbit is loose, it could fall off. So you'll take the acorn nuts, and now you're looking at black acorn nuts on a black PCB. So let me know if this poses a problem. I'll try to tilt it for you. Maybe the side view would be better if it focuses. I'm going to put that on the screw. And I'm just going to hand tighten it for now. You could use the little plastic wrench in your kit if you want. I'm going to do the other one. Okay, so mine is put together now. Pretty happy with that. And you can see there's no space between the nylon nut and the board. So everything is tight the way it should look. And maybe give me a thumbs up or thumbs down out there to see that others are getting by okay with this step. Okay, good, good. And Josh, maybe if you want to post a link in there for the actual assembly instructions in the chat too, if you can get those.
Will do.
Looks like Matt Kinman was unable to get on an airplane with 4 of these in his pockets.
That sounds very like he's speaking from experience.
Yeah. Okay, so what's next? So we need the servos. All right. So I'm going to get these servos out and the battery pack. Laying things out here. Hopefully you can see it all. And batteries are always an issue with robots. 80% of our tech calls are related to power supply. Okay, so fresh batteries. And I'm going to just connect the servos and the power supply to the Cyberbot board. So first, I got my batteries all loaded up. So that would be 7.5 volts. Each of those is 1.5 volts. And I'm going to plug it in like so. And then the two servos. Okay, the servos have on them a white, red, and black lead. So one is for signal, one is power, one is ground. And these are going to go into pins 18 and 19. Let's give you a close-up look because this is also another area where we can get into trouble. I know a lot of you guys are document camera heroes out there, but I still have trouble like getting the orientation all right when I'm looking at my screen and trying to position things. Okay, so what are we looking at? So we see on the board pin 18 and 19 up here, and then you see little labels, BRW. And you'll also see what we call a jumper right here. And it has two places it could be, on 5 volts or VN. And if you put it on 5 volts, which is where we want it, and that's how we ship the boards from Parallax, then your motors will get 5 volts. So you should just be able to leave it. So if we plug the motors in, we want the white lead to go where the label is for P18 and P19. So I'm going to plug one motor in first. And some of the mistakes you might make here, or a student might make, is they will reverse the polarity. Okay, servos are not keyed. You can put them in backwards. Nothing will happen. It just won't work right. Or they might shift it off one. Okay, so one of us here today will have this problem, I guarantee you. But we'll find it and we'll fix it. So I'm going to plug in the second one right next to it. So there we go. I have those plugged into 18 and 19. I've plugged in the power supply. And I'm going to zoom out. And you can just follow along at this stage if you want, or unless you're also doing this. And I'm going to plug in the USB cable. And what we're going to do is write a script that sends a value to the servos that should keep them still, so that we have full speed control when we send a value of 0 or 100 or minus 100 in two different directions. So I plugged in my USB cable, and my power switch on the board is on position 0 right now. You'll see all Parallax boards have 3 places the power switch can be, on 0, 1, or 2. And 1 is everything is on but the motors, excluding motors. Then position 2 is more on, everything is on, including the motors. So I'm just going to put that in position 2. Okay, so the things I did are I plugged in the servos, I connected the power supply, I plugged in a USB cable, and I put my power switch on position 2. And I made sure the jumper was on 5 volts. So that's a lot there, okay? And if you feel a little bit intimidated by all that, that's okay. It'll become second nature soon. So now I want to write the script to send to the servos and just show you how to do that. This is the process of centering them is a little bit tricky for students who've not used a screwdriver, because who have also not used little delicate electronic parts, because they can really, gronk them around, and it takes a very gentle touch. This is a better job for somebody who's very gentle at handling things. So I'm going to go back to my Python editor, and I'm going to finish typing the code that I was typing. Josh, can you verify that you see that again?
Yep, I can see you typing.
Okay. So the values, the arguments you could use here are minus 100 to plus 100. And you can imagine one value is full speed counterclockwise, and then the other is full speed clockwise. So I'm going to send 0 and 0 to both of them. And I'll just copy this code right into the chat if you just want to copy and paste it. So there it is. And I'll even enlarge it so you can see a little bit better. And I'm going to put the document cam right next to it. So I'm sending a servo speed of 0 and 0 to pins 18 and 19, which are both connected to the motors. So I will hit connect. And then I see the flash button, and then I flash. And I will switch back to the document camera and enlarge it. And okay, my motors aren't doing anything. And that is because, and you guys will get to this stage too, and maybe your motors will be turning or not turning. One of them is not working. This is really weird because I did have an issue with the same kind of behavior with one motor not working. So I'm going to focus on the one that is working first, and I'll figure out why the other one is not working. So the motor's turning, okay, and I gave it a value of 0. Now, what I want to do is I'm going to turn the motor on its side. I'm going to look for this little hole in the case, and you will see what's called a potentiometer, a dial inside of that hole. And that dial is shaped with a Phillips screw head. See that? Okay, and it's plastic, and it only turns about 90 degrees. And I want to turn that dial until this motor stops turning. So I'll take my screwdriver and let's put it in there. And again, this is where you just need to be very gentle. Just handle the screwdriver really loosely between your index finger and your thumb. And then as you turn it one way, the motor will turn. And if you rotate it opposite, the motor will turn again. Somewhere in between, the motor stops. So what you want to do is find the place where the motor stops and then remove your screwdriver. And that is a centered servo.
In electronics, we call that the quiescent point.
Yeah, so since you've done some of this, tell us about your view of this step as a teacher, Mark. Difficult sometimes?
It's not as bad as root canal work, but it's kind of like a kidney stone, you know? It can be annoying at times, but I think usually I put the code on the board and then I have the kids type it in themselves, and then they can realize, you know, what they did wrong, and they can realize the syntax. So, but that's a short code. It's one that can be typed in quickly. So.
Yeah, there's not much to it. I mean, this is actually shorter than the basic stamp code too, one line. And if you're new to controlling motors, what's really cool about what you're seeing is the Cyberbot library maintains that motor control signal for you. You just change it when you want to change the speed. But what's really happening behind the scenes is a little more complex than that. There's a series of pulses that are being provided. So let's see from all of you how the servo centering has gone for any of those who've done it just now. Maybe you can shout out or ask questions.
I have a question.
Yeah.
So if neither one of the servos are turning after we flashed the code, is there a way to troubleshoot that?
Yeah, that's exactly where we'd like you. So let's make sure of a couple things. First off, is your power switch on position 2? Let's make sure of that. So is your power switch in 2?
Yes.
Okay. Then let's look at how the motors are plugged into the board. And I'll give you a zoom in on that again.
Ken, are we flashing on 0 and running on 2?
You could actually flash on 2. Yeah. Oh, so one thing I would suggest too, maybe the issue, if you are plugged in right, okay, there, this came into focus. So you could flash it on 0, 1, or 2. But sometimes with the microbit, if you don't see any movement on these motors, you might just need to reset your microbit. And how do I do that? And I found this to be the case with the version 2 that we're using here today. So if you flip the board over, there's that reset switch right here. It's by the yellow LED. Just press that button and then your program will run. And make sure your switch is in position 2 and that your motors are plugged in properly. And by properly, I mean like this. Again, this is black on black, so it's hard to see, but the white lead
No, they
is
have not.
located towards the top of the board. And then the red one is of course in the middle, the only place it could be. And I have this one plugged into pin 19. And that your battery pack is good. That's the other requirement. So did that get you up and running?
Yeah, it was my pins.
Oh, okay, good. All right, who else is having trouble? We
I
need
am.
more trouble. Okay.
So I'm having a similar issue. 19 servo that was plugged into 19 worked. I got that to stay still, but the one plugged into 18 hasn't moved at all.
Yeah, it's really interesting. So I had the same exact behavior on my board. And let me see if I have been able to solve that.
So
And this is something I've seen with the new Microbit 2.0. I'm not sure what solved it for me last time. I think resetting the Microbit did.
But Dan in the chat is saying that doing that worked for him, resetting the microbit.
Oh, it did? Okay.
And then
No, I haven't. I've reset it and it's still nothing's happening.
On either motor?
Yeah.
Okay.
I reset my P18 still is not turning.
So we have trouble with P18 then, kind of, it seems like universally, huh?
For those of you who are having trouble with P18, try switching the servos from P19 and P18, see if you can still get the whatever's plugged into P19 to run, making sure that it's not a servo issue or a battery issue.
Yeah, so if you take the servo that's on pin 18 that's not running and then put it on 19, you can center it that way. And I think in the meantime here, I'm just going to look and see if I could figure out why 18 is such a problem.
Yeah, the way I ended up
That
doing.
solved it.
Yeah, you have to hit the reset button on the microbit, and then both of them will start moving at the same time.
Okay,
Yeah, after
so
you've unplugged it so it has no power and then plugged it back in, or move the slider switch to 1 or 2. Yeah.
okay, thank you. Yeah, so again, this is new for us because we just got these in stock, so you might be doing a little bit of troubleshooting. Okay, so the solution was to repeat the process again. It was go from position 0 on the slider switch to position 2 and to reset the microbit, right?
Yeah, I actually unplugged the microbit completely, like with the USB.
Like that, okay.
Yeah, and then turn the slider switch all the way to 0.
Okay.
Yeah, and then turn it back on and then press the reset, and that seems to.
Okay, so what you described is cycles the power on the microbit, kind of like when your router doesn't work at home.
Yeah, that fixed it for me.
And that fixed it for me too. Good. And how's the servo centering going for everybody? Is that tricky or are we getting it?
So it
No,
didn't.
it's not on at all.
Pardon? Repeat that again, please.
It's not going at all.
Okay. And on yours, let's see. Let's go over a few things then. You have the code that I have right now, right?
Yep.
Okay, and what we should check on yours, when you go to load save, let's just make sure that the cyberbot.py file is there.
Where do I find that? I loaded
Okay.
it, but it's not showing up.
Go to the third button on the top of the editor, load save,
Uh-huh.
and then
Oh.
where it says show files, does it say 2?
Yeah.
Okay, and one of them is cyberbot.py, right?
No. Yeah, it is. One of them is.
Okay, so you got that, and then your code looks just like mine.
Yep.
Okay, and you did flash it, right? So you did connect like I'm doing here, and then flash, right?
Yep.
Okay, you're in good shape so far. And then the next thing would be that we check your circuit and see that it kind of looks like mine. So you've got the microbit installed like this.
Yes.
Okay, and obviously USB cables plugged in, should downloaded. And then how are your motors plugged in properly?
Yes.
Okay, and so you see the white lead is nearest the top of the board where there's a label that says 18 and 19.
Yes.
Okay, and is your jumper in place? That little black piece right here?
Yep, it's right there.
Okay, and your switch could be in position 0, 1, or 2. When you flash the code, your power's plugged in too, right?
Yes.
You see 2 green LEDs by the power switch.
Mm-hmm. Yes.
Oh, all right, then flash your code again. Oh, and also case sensitivity in Python, as someone just pointed out. Do you use all lowercase in the code?
Yes.
Okay, so go ahead and flash yours again. And then we'll have you do a reset, like someone described.
Yeah.
Okay, and also I'll get a breakout room for you too in just a second.
Yeah. I think we need a breakout room. 'cause
Okay,
it's
cool.
flashing error on it or something.
All right, that's probably a syntax error then. And others might have this. So if you copy paste my code into there, it should carry the correct syntax with it. So try that, and then I'll make a breakout room, and then we'll move on to talking about the robot build.
There seems to be an issue with running both motors. I've just been playing with it, and every time you hit the reset button, it'll sometimes start in both of them. Sometimes it'll just start one. Sometimes it'll start both, and so forth and so on. So there might be
Interesting.
some issue. Yeah, because right now I have both of them going. And then I reset. Yeah, now
Okay.
it's doing both. It's going to make a liar.
Can I
out.
just,
Sarah?
Yeah. Okay. Sorry, I just an observation.
and then the other, and I tried switching them back and forth. And when I flipped over the plate on the back, one of the male pins had, once I took my screwdriver and just sort of tapped it back all the way through and into the piece, both started to work. But one of the pins is loose in that slot.
Oh, one of the pins that contacts the microbit?
No, not near the micro.
The servo connection pins?
One of the servo connection pins, not attached to the servo, but the male pin that was coming out of the board. Once I tapped the back of it and tapped it back into place, it made connection inside the
Sounds like yours were not fully soldered.
part, and now
Okay,
it
maybe
sounds like
yours.
it, but it's working now.
Okay.
It's working now.
Interesting. Kind of a loose connection sounds like is what you had. Okay, so breakout room for those that are having trouble that want to resolve this now. So I'll make one. And
Ken, an observation on mine, if I flash it on 0 and then run it on 2, I get both that work fine. If I try to flash it on 2, nothing happens.
Okay, so that's what we need to know. So flash it on 0 and then run it on 2. And I think that might fix the other gentleman's problem. So I've made a breakout room and anyone can go there. I think you could self-choose. Let me know if that works. I'm not an expert with the breakout rooms in Zoom. So if I didn't do that correctly.
Matt will be in the breakout room to troubleshoot.
How do
Okay.
you join the breakout room?
It'll pop up in the lower right corner of your Zoom window that says join breakout room. It's kind of the faint button there.
Maybe someone can verify that is
Yeah.
working.
It's working. I see it.
Okay, and make sure I guess you'll disappear when you go there, so you won't be able to tell us.
I'll give you a quick hint on the breakout rooms. I don't use them at all. I have everybody come back to the Zoom if they need help, and then it's instant breakout with me. It's so much easier that way.
Oh, how'd you do it again, Mark?
I have everybody, after we have the class meeting, I have them leave and go work on the programs. If they need help, they come back to the Zoom, and that's our breakout, me, them, and anybody else that needs help. So
Oh, you
there's no
deal with it all at
breakout rooms.
once. Okay.
I don't deal
Really
with breakout
smart.
rooms at all. I
Yeah.
don't like them.
So
Yeah.
yeah, I have trouble managing them. So what I'm going to do is move on to the robot build, and then I will just stay on here to assist anyone that needs anything afterwards. So the breakout room will kind of be done in mass for anyone having trouble. Okay, so robot building. Build your
And I have a-
Cyberbot. Yeah, question.
Good question. As you're looking at the Cyberbot board with the USB connector to the top, the lower right corner of the board with the LED down by the servo pins on my board is blinking.
Is it red?
Yeah.
Okay, that's a low battery indicator.
Okay, so these are fairly new rechargeables. Should I move the jumper or not?
Yeah, you could put it on VN, but I think it will still blink. So rechargeables are 1.2 volts, right?
Right.
And if they're a little low, let's say they're a volt, your whole power supply might be below 5 volts. So if you have a voltmeter to check it, I'm not sure where the low battery indicator light flashes, but it might be 5 volts.
Got it. All right, thank you.
Yeah. And report back too, after you put a voltmeter on that power pack. Okay, so the robot
Can I ask
build.
a quick
Yeah.
question as you're starting? How sensitive are the servos? So I centered both of them, and I noticed that if I just flip my switch to 2, maybe like the jolt of flipping it will spin both of them for a moment. Is that?
Yeah, and that's
typical?
normal. So yeah, what's happening is the IO pins on the chip that are attached to the servo motors toggle high and low just when you boot them up. And hopefully with robotics, it won't be enough to cause your robot to veer or go away from the way it starts out, like change the angle. But yeah, that's normal. You'll see that twitch.
Great, thanks.
And as long as they're not moving when you send those values to 0 and 0, then you're in good shape. Okay, so the build. I'm showing right now the page where you can start building the robot. And there are 2 ways you can put this together. I'll demonstrate it with the camera again. Actually 4 ways you can assemble the robot, and there's really one favorite way that I like to do it. So I'm going to take the chassis here and I'll enlarge this so you could see it. And we'll do a view from the bottom first. Okay, what I'd like to draw your attention to is how these motors went into the chassis. So you could mount them with what we call the spline, all right, or the axle for the motor closest to the middle of the robot, or you could flip this motor over and then put this axle closer to the front. I like to assemble this more like you would see a Roomba with the drive wheels nearest the middle of the robot because it turns much better and it turns on a tighter radius. Okay, so now it depends what you connect to the front of your robot. If you did put the motors forward and you had something heavy on it like a gripper, then it's okay because the weight is distributed forward, but you just don't want to set it up in a way there's so much friction on the back wheel. So this is the way mine looks. You can put the motors on the outside or the inside. Okay, and by outside or inside, here are the servo tabs. This one's mounted on the outside, but definitely mount them so that the axle is more towards the middle of the robot, as this one is shown. I don't even think I have one here. It's built the other way to show you, but this will give you a tighter turning radius, lower friction on your rear tail wheel, and just better performance overall. Is that clear? Okay. All right. Because one thing I'm not is a teacher. So you guys got to keep me going straight here. Just want your robot build to go nicely. So you'll get to a point where you have the chassis assembled like this, and your wires will come through the top. This process will take you about an hour. There are two types of nuts in the kit. There are what we call nylon lock nuts, and there are also machine nuts. So I use the nylon lock nuts because they go together tight and your robot will never have to be tightened again. Let's look at them. I think I can actually maybe even draw on them just so you could see. So this is the nylon lock nut, and the other are machine nuts. They don't have the nylon insert and they can come unthreaded. So use the nylon lock nuts. It will take 8 of them to mount 2 servos. And once you get the chassis assembled and you have your wires cleaned up, and I really want you to do a good build here so that you don't have wires that are hanging out by the wheels that can get tangled. You can bunch them up like I've done with a zip tie and then tuck them under the servos. And here's another thing to look out for that I should show you before we leave the bottom of the robot. Notice the battery pack is held in with a flathead nylon screw. There we go. And you could barely see it, right? Whoops. There we go. So that screw is a flathead nylon screw, and it attaches to the standoff on the other side. The instructions are clear, but just be sure you use the right one here. We don't want
And I
any
have a
metal.
question for you.
Yeah.
And for maybe the teachers too. Do you have your students disassemble them at the end of the semester or at the end of the unit for the next group to reassemble, or do you just recommend keeping them together?
So we keep them together for pretty much for the year or for the semester. And I have most teachers will take them apart and methodically manage all the components into, storage bins for the summer, but have the student rebuild it afterwards. Yeah, I think
might want to lay in a supply of those nylon nuts because kids like to really torque stuff.
Yeah, that's what I was wondering about.
Yeah, that's why you have at least machine nuts if you need extra in the kit. But yeah, any other teachers out there want to comment on how they manage that part with the students? I'm a fan of rebuilding, having them build them on their own. And then if you're missing parts, we can provide them. We have several bags of consumables like that. So you'll get the robot built up, and then you'll mount the Cyberbot board on top like this. And then you'll plug your motors back in, and then you're ready to go on to navigational type stuff. And start really exploring this whole world. So we went a little bit longer, but that's our first day. It'll be easier on Wednesday. And so your goal is to get the robot assembled, okay? And then in the tutorials, make it move. And on Wednesday, we will go over all the different ways to make the robot move. And I'll show you how speed control works, acceleration, deceleration. We'll write some functions and pass some arguments around to make things a little bit easier. And just get familiar with moving the robot. And then we'll actually build our first circuit, which will look like this, whiskers. Okay, these are his touch switches. This is a physical contact closure. So when the robot hits something, we could back up and turn. So we'll get into circuit building. So at this point, we can end the session and I can stay on board for all tech questions like Mark mentioned, and get any robots running that are not running, or any servo centered or whatever, wherever we're stuck.
I have a couple questions for you in the chat. If somebody has a 9-volt adapter, can they use the 9-volt rechargeable battery instead of the 5-volt?
Generally, no. The Microbit, okay, so the board will take, the answer really is the board will take 6 to 24 volts. All right, so yes, but not advisable because 9 volts can't source enough current for very long. They're just not made to provide, 1,000 or 2,000 milliamp hours of capacity. They're made to provide higher voltage.
And then another question's more concerning the Zoom recording. But you said you were going to email out the link for the Zoom recording.
Yeah.
Yep. Okay, just checking.
Yeah, I'll send that in like 2 hours or so.
I have a question.
Yep.
My metal frame on the robot came with a slight bend in it. Is there a way that I can safely unbend it? I don't want to put too much pressure on it in case.
Yeah, you could physically bend it. I guess that it's probably on the back part like this that it's bent. Is that
It's on the side where the wheel.
one of these? Yeah, you could bend it. So they should be 90 degrees from the platform, I guess you'd call it. So straight up and down. You could do it in a vise or you could use your hands and do it. It's 6061 aluminum and it's quite pliable.
Okay, great.
Sure. And if anyone has any issues like with parts missing or broken parts, I'll replace them. Just send me an email and we'll get that done for you. And for those still hanging around, more questions?
Where do I put that jump switch again, the jumper?
On VDD, 5 volts is what VDD is. It's labeled as, I need to look at a board myself. So you'll see VN and 5V, and you'll put it on 5V.
Okay.
Can you show what that looks
That jumper?
like underneath the camera? Yeah, because I think that's the thing that I don't have.
Okay, so there should be, and I'm going to work for a minute here to get the focus on this correctly. Okay, so I'll actually remove this jumper and then I'll put it back so you can get a look at it. So the jumper looks like that. It's a little plastic part and it connects 2 of these male headers together inside of it. And so I'll put it between the middle post and 5V on the board. So your board should have come, pardon? Here's a decent picture of it installed so you could see it right here. I'll draw around it for you.
It's black.
Yeah. Did that help you with the jumper?
Yes.
It's hard to see and it's really hard with our chubby fingers to remove it and put it in right.
And I found the small bag for the Microbit screws and the nylon.
Yeah, they come in their own little bag about the size of a quarter, right?
Yes. So I apologize for that.
Well, when I opened up my box, of course, of all people, the boss, I thought mine was missing parts. And I immediately called the kitting guys and they said, oh, they're in a little bag. You just don't look hard enough. Well, a lot was achieved, Josh, wouldn't you say?
Definitely, definitely. I feel like we just started.
Yeah, it's a lot for an hour. It's a tremendous amount.
Yeah, it went really fast, which is good for me. I was having trouble staying awake, but my wife brought some chocolate.
All right, pass it over, Carl.
I wish I could. I don't have my robot yet, but it's fine. We'll be headed back to the school building on Wednesday.
Mm-hmm.
And I'll get it there. But you covered all the problems that I had in building the robot last time around. I had one wobbly wheel. I stripped like 2 or 3 lock nuts. So the more times I tried to make adjustments and rebuild the whole thing, it just got worse putting
Yeah,
it
those
back
lock
together.
nuts, once they've made up their mind, you're done for.
Yeah.
Yeah. So I have a lot of experience putting little things together because I used to build RC airplanes. And what I like to do with these lock nuts and model railroads and all kinds of stuff is first just get the screw going without the screwdriver, or with the screwdriver, but without any force, so that you can feel the nut threading into it. And you should be able to get 2 or 3 turns and everything should look lined up. And at that point, you're ready to engage the nylon threads by putting that little black plastic wrench on the other side. And this is tough. You know, half the people who do this, and it's a lot to ask of kids, I would say. So they need a little bit of guidance as well on it. I mean, you really truly have to show them with a document camera and the pieces how you do it. And so the machine nuts are easier if you don't want to use the nylon lock nuts.
Is there any way you can show me that little piece that's attached to the 5-volt? Because I can't see it in your picture and I can't see it on my tab.
Yeah, sure. Let's just see if we can get the document camera to really show it off properly.
I'm not seeing.
And you really shouldn't even have to adjust because it should already be there and installed in the proper location. Okay, so here it is, and I'm going to draw a circle around it.
Maybe that's what my mistake is. Yeah, maybe it's already in place. Maybe that.
Yeah, it is in place already. So it's a little black, thin piece.
Like a cap. Okay.
Yeah, I'd say it looks like a cap.
But my motor's.
So your jumper's in, but no turning of the motors?
My code. No, occasionally I get 1 to work. I can get 2 to work if I hold the.
And by getting to work,
back end of the mail part.
Do you mean you are turning the potentiometer and the motor's not centering? Describe that a little more.
So over here on my my code, I hit flash. I'm a little suspicious. I've been using microbits before, and I know that you should be able to see the code upload. You should be able to see the flashlight light on the back, and I'm not seeing any flash at all.
How about this? Flip over your board and let's see if you see the LEDs flashing on the microbit. There's a transmit and receive LED on it that you should see flash. In fact, I'll show it on mine.
1 orange flash.
Oh, okay. But you didn't see the message on your.
Oh, I did before.
So I'll turn it over and show you what it looks like on mine.
I have
kind of
my thing set
wondering.
to 2.
It seems like maybe that message came and went so fast you didn't see it. So when I press flash, I see. Actually, on my microbit, the yellow and the red did not change at all when I flash.
Okay.
So it
maybe
is.
I'm expecting too much of that.
Yeah, I would expect most parallax boards, you see the LEDs flash during transmit and receive, but on this, they seem to be static. And so the motors are plugged in, but you have no movement on them. What you could do is put the power switch on 0 on the board and then unplug the microbit.
Okay.
And then plug the microbit back into the USB cable and then turn the power switch to 2.
Mm-hmm.
And this should generate signals on the motors.
One's going.
Okay.
But the one that's on the right, the one that's sitting on the right, which is number 19,
Uh-huh.
is not going.
Okay. Then two things are possible. Maybe it's already centered.
No, I don't think so. And when I put the screwdriver on the at the back end, I can get both of them in.
So when you put the
I don't know if you'll be able to
screwdriver
see this.
on the one on 19, okay, let me just enlarge your video here. Get a closer look at this.
Put my screwdriver down on 19, I can get the second one to go.
When you say the second one, you mean
The
the
19 one.
Okay, so it is
It's
turning.
spinning already. I don't know if you can see that. The second one doesn't spin until I put my screwdriver down on the back of one of the pins from 19. Engaging that the male and the female aren't tight enough in that space.
It sounds like you were asking previously, you pointed out that your headers may not be making contact, right? That those male posts may not be soldered in. If you turn your board over, do you see solder on the bottom of the board? Where those
In that one
3-pin
space,
headers?
I don't. I see probably copper or brass or something like that.
Can you actually remove the header? It sounds like you have an incomplete manufacturing process.
I remove the header.
Yeah, so that 3-pin male header where you plug the servos in, can you pull it out of the board?
Yeah, I did.
Oh, show me then. Turn the board over again.
See the back of the board?
Yeah.
You see that one piece right there that's not
Yeah,
soldered?
that one's not soldered. You're exactly right.
On this side, I can see my pins are looking healthy, although at the moment they're looking healthy. For a while, that one of them was going all the way through.
Okay, so that's interesting. It sounds like that looks like we did not solder that. Do you have a soldering iron?
Oh, that's right. One's not soldered.
Do others see this too?
Yep.
That's the back right there, that little guy right there.
So who else has one that has one of those pins unsoldered? Anyone else? Or was everybody able to make both 18 and 19 motors work? Sarah, you kind of froze when I was asking you a question, but do you have a soldering iron?
I do.
I think, yeah, just put a soldering iron on it, add some solder there, and I think that'll fix it.
Okay. All right.
And if you have any trouble,
excellent. Thank you.
Yeah, let me know how it goes too. If you have any trouble, I'll ship you a new board.
And Ken, it looks like Leon also.
Let me see what I can do.
Leon has a similar issue. Yeah, and so what she was pointing out, and it might be interesting if others have this, is right here. One of these was not soldered. Okay, so these are where the servos connect. And as you can see, I have a low battery indicator too. So one of these was not soldered properly. Or fully. So she'll take a soldering iron and carefully add a little bit of solder and that will fix it. But Leon, you have the same issue?
Yep, the exact same issue.
Really interesting. Okay. I wonder how they passed our test. Curious if anybody else does. Anyone else observe that too, since we still have a couple dozen people here?
I've gotten 18 to work, but I'm not sure it's working with the code. So I think I need to see the servo centering servo instructions again.
Okay. So that's right here. And I'll also put into the chat the code for that, or the link to the tutorial.
Okay, I was looking for that, but I didn't see it. Thank you.
There you go in the chat. So that'll help you. Yeah, it's on the Build Your Cyberbot tutorial series. And navigating them is a bit tricky. Once you select the main tutorial, you can navigate on the left side or on the bottom right side. We'll move you to the next page. And the code, if you want to see it, is this. I could just copy and paste it back into the
Oh,
chat.
I got the code. I just, and I
Okay.
was playing around with it, but I would, like, I need to actually center them. So I wanted to make sure I did that. Thank you.
Yeah, you're welcome. Curious too, if anybody else observed a low battery indicator. I just had one, but my batteries were fine.
And I did confirm after putting in a voltmeter that the battery light was due to, it was a volt low. So.
Oh, you were low. Okay. Yeah, strangely on mine, it's a different problem than you're all having, but I have a flashing red light on mine, but my battery, actually now that light has gone away. Okay, that's interesting. But my power supply was fine. I just checked and it was 7.5 volts.
And you said if we are experiencing a problem to push the reset button, which is just to the right of the AC adapt, the plugin.
No, so it's on the bottom of the board, right
Okay.
next to the USB cable.
Yes. Okay. Got it.
Right here.
Got
Yeah,
it.
and there was one additional step that somebody mentioned that I've not kind of proved this out yet, but I think that the power supply cycling of the microbit. So if you disconnect, if you put the power switch on 0 and
Okay.
then you disconnect the microbit from the USB cable, that cycles the power on the microbit. And I'm not sure there's a difference between pressing reset. I don't know if reset with the USB cable connected fully cycles its power. I don't think it does. Something I have to find out here in the next day. So I like to just disconnect the USB cable entirely from the microbit and put the switch on 0.
Okay.
Yeah, I'm curious too if your servos are moving now. I hear someone's.
That's mine. Yeah, they're
Okay.
moving.
So cycling the power on the microbit. Did you press the reset button with the USB cable connected? Or did you? Okay. How's everyone else doing? Janet, how are you doing? Yeah, you're on mute. I want to thank you for coming. I know it's getting late there. Still can't hear you, but I know you're saying things. I'll unmute you. Actually, you're having trouble finding the button.
Okay, yeah. I'm
There
having
you are.
trouble finding the screen. So when I turn it on, they both move, but then they stop.
They both move and then they stop?
Yeah, so I
That's
don't know
peculiar. Okay.
why.
And you have it on number 2 on the board, right?
Right, number 2.
And when you say they both move, it sounds like they both twitched.
They
not they're
twit. Yeah,
moving
they didn't
continuously.
really spin.
Okay.
They tried.
All
I
right.
changed the batteries because I had rechargeable, so I put regular.
Okay, so in that case, it sounds like the power is getting to the motor, but maybe the signal line, maybe the motor's centered. So if you put a screwdriver into that motor case.
Okay, hang on. Let me get
Yep.
the screwdriver.
And you turn it a little bit, I'd like to know if that motor turns.
No, nothing is happening.
Okay, and you're on, let's make sure you're connected to 18 and 19 on the board.
Yes, 18, 19, and it's the whites on the top and then red and black.
Okay.
And I think I'm soldered. I don't see any like it's
No open connections
looks
on the back.
metallic, yeah.
Okay.
Looks
Is your
metallic.
power switch on number 2?
Yes, I have 2 lights on, 2 green lights.
And you've downloaded the code, right?
Yes.
And you added the Cyberbot module to the Microbit?
Yes. If I was getting an error message, and so then I redid it. So now I have from Cyberbot import and then just a bot 18 servo speed.
Do you have the star after import?
Yes.
Okay.
Let me try it again. I don't.
Can you share your screen?
Turn it off.
I'm going to stop share. Maybe we should look at your screen.
I don't think so because I'm on a different like tab.
Oh, okay.
I don't know. Yeah.
Okay, so your code though is from Cyberbot.
Mm-hmm.
You could share your screen. Just try desktop, and if that doesn't work, then try application.
Oh, there we go.
Yeah, I think I had to go to the Zoom icon. That was the trick. Okay.
Okay, this
All
looks
right.
good to me. And then the second button over, which is the connect button, click on that. Okay, and then the first button on the left, which is flash.
The flash.
Okay, and also on your display here, there's something I should tell you. If you do Control plus.
See, now I'm getting an error. Line 2.
Oh, okay. All right. Before we look into that, do this with your display. Do Control plus or Control minus until those icons have a text label under them. And if do Control minus again. Oh, okay, there. All right, I'm looking for the text labels under those icons. They show up when you're zoomed at 100%.
Oh, it'll give you the,
Yeah.
okay.
So right now you can't see what the labels
Well,
are.
if I hover over to it, it says flash.
That works.
It's giving me, okay.
Go to load save, the third one.
Okay, wait, you're in my load save, okay.
And
okay,
then,
download project
no,
text.
I see
do
the
you want to
problem.
see?
Yeah, so that is missing the Cyberbot library. So go click on or browse for file up top.
This one,
Yeah,
okay.
and then that zip that you downloaded. Might you know where that is?
Okay, so.
And I can't see where you're navigating to, so.
Okay, so is it the microbit program.py or .hex?
No, it's cyberbot.py is what you're
okay.
looking for.
Cyberbot. Okay, here's the downloads.
And you'll need to unzip it.
Okay, wait.
First.
Okay, I have a lot of stuff.
Right, this is where we all get. This is like the file management chaos.
Yeah. Let's see. And here's the folder. Okay. Cyberbot. I have guide, webinar, MicroPython, mic on zip. Is that it?
Do you see any zip files in that
Let me
collection?
see. No, it says invalid file. It won't take it
That's
in. Hang
because
on.
it's zipped.
Yeah, hang on. Let me go to Finder.
And what I might just do is email you the right file right now.
Okay.
And Leon, do you have a soldering iron as well?
Nope. unfortunately not allowed to have
Oh.
that at the middle school level. So
Oh, okay. So you verified you have an open connection there, huh?
yep,
Okay. Where are you located?
I'm in Arizona, Phoenix.
Arizona. Okay, so I can get you aboard by Wednesday.
Okay.
Could you have my email address? Could you send me an email?
Yeah, I'll send you an email.
Okay. So sorry about that.
Oh, it's okay.
Yeah, you guys are used to more challenges this year than this little problem, but to me it means that we have some kind of failure in our factory if more than 2 people had them.
I was able just to switch to 2 servo motors and get them both centered.
Oh, good. And so you know, for the class, you could use the other 2 as well. You could use 16 and 17.
Okay.
So you're not totally down, but you you just have to change in your code the constants. All make sense to you?
Yeah. Yeah.
Okay. Cool. Yeah. So we have a solution for you. And for Janet, did you find the
No, I
zip?
don't know why I did the download with the 3 files, but it's coming up Cyberbot MicroPython, VO
Okay.
8-0
Yeah, you're in the
zip.
right place. Now
But
unzip that.
it's not, I don't know why it's not just opening.
You have to unzip it.
Okay.
There's
hang
a zip
on.
and a zip. This is the Russian babushka doll again.
Oh, okay. All right. So let me see. Oh, wait, it's expanding it. Hang on, maybe it's doing it.
And remember, Windows now, if you click on a zip, it'll show you the contents without actually unzipping it.
Okay.
So you have to right click and unzip it.
All right. Yeah. Okay. It's trying. I mean, usually it just, I haven't, I don't know. It's not doing it. It's just making a copy of the folder.
Is that right?
For
Is
me?
it?
Yeah. Oh, wait. I got something different. Okay. So which one am I looking for? I have cyberbot.py.
Bingo.
Okay.
And so
so I could find it now if I go into the editor.